Hey guys, so today you and I are going to talk about performance issues. So let's get into it. So the question in question was, Frederick, I am inheriting an old code base which is huge, poorly designed, and has no documentation. I don't see the problem, dude. Isn't that you speak as if there's a different type of inheriting? How do I start fixing performance issues? Well, I'm gonna give you a silver lining. This is the easy part. I'm fixing performance issues, or at the very least identifying performance issues. That is probably the easiest thing you can do when you're inheriting a really old and large and very poorly designed code base with no documentation, which is like just for most of us, it's just in second generation code. That's usually what it is. So the good news is that if you want to fix performance issues, there are quite a lot of tools that will allow you to trace the problem. Now, you're not really telling me what type of system that you're like. I'm just for simplicity's sake, I'm going to assume that you're dealing with a monolithic application. It's a single node system, or like it's a monolithic application. We're not talking about microservices or a distributed type of thing, because if that's the case, the work is still the same. It's just much bigger. So the as I said, the good news is that there's quite a lot of profilers out there. So the first thing I would do is that I would go and have a look at starting up the system. And then I would, well, first and foremost, you're not really saying here what type of performance issues you're dealing with. Are you talking about execution time? Are you talking about memory consumption or memory leaks? Are we talking about something like kind of what are we looking at here? And there's quite a lot of monitoring tools that will help you evaluate what type of system that you're dealing with, or like where the issues are. So I would take a look at memory profiling this thing. If you notice that there's a leak, that should be fairly straightforward. There are many memory profilers out there that you can use. Some are language specific and some are not, where you can just see, all right, where like what are the allocations looking like. Is if you're this, I'm not sure if you're in a garbage collected language or not, but I'm assuming you are. And so is the garbage collector actually cleaning everything up, or are there dead references that are not being cleaned up correctly, etc., etc. That thing is fairly simple. In terms of execution, it's also there's quite a lot of tooling today that will give you the hot path through a call. So let's say that you have a specific feature, because usually you're not, when you deal with a performance issue, you're not dealing with the entire application. Because if you're dealing with the entire application, well, it's it's mostly the same process. It's just that it's going to take more time, just as with a distributed system. So usually you start with figuring out which feature is unperformant, and usually that's going to be a network call. Some user is trying to do something and it takes too long to do it, so you simulate that call, and then you look at the hot path, and then you can see usually you can get a very nice call stack where you can get the execution time of each function that was part of that feature. It's very similar to the stack trace when you have an error or something like that, where you can just see, all right, so I'm spending a lot of work in this function. Let's go and look at that function. What is that function actually doing, and what can we improve it in some fashion? And this is where things such as understanding computer science and object notations and things like that becomes really useful. Good God, it becomes useful. I remember I was looking at this was a while ago. I got a story for figuring out why a specific endpoint was very unperformant. And so did exactly the thing that I just described. You pull out a profiler, whichever you might use, and then you go through and see, okay, where is the hot path? Like this, like you're sending a bunch of requests. You can do it. Like, I mean, I was doing the poor man's version of it, just sending a few requests manually. If you really want to do it right, you can do stress testing. because the issue, you might find that the issue is only going to show itself if you have a certain amount of traffic. So being naive like I was and just sending 1 or 2 requests might not actually give you any insights, because like everything's working, and the only time it really starts becoming a problem is because, I don't know, you have memory, there might be a memory leak, or there might be that you have so many requests in production that it's actually keeping your resources capped, and for some reason, I don't know, you're reading an entire buffer of data into your system instead of streaming it and stuff like that. But if this was a very simple thing, you just basically made a call and it was unperformant. And so I went and had a look, and I noticed that, well, in order to execute this call, we read in hundreds of thousands of records into like right into memory, and then we sort those, and then after that we filter out the things that are not unique or something like that, and then it kind of just went from there. So it was basically a big transformation from raw records from the database into some output. And I immediately, as I recall it, the only thing I did was, again, this was the lazy man's way of doing it. I could have done it in different ways as well, but for that I just switched the filtering of the sorting and the removal of duplicate records, and immediately the whole thing went much faster. Because if you're going to sort an array of hundreds of thousands, if not millions of records, well, you can probably save a bit of time if you already know that you don't need all of those records, because sorting is expensive. And that's that tiny little thing actually made the difference. I mean, of course, we could have done it in different ways. We could rewrite the feature, and those are the sorts of things that you need to think about. When you realize that, well, this is a unperformant piece of code, you're going to have to reverse engineer it and figure out, okay, why is it unperformant? Ask that sort of question, and then try to understand, why is it working this way? Is it because the developer didn't optimize this thing, or is it because the feature is designed in this fashion? And now you're going to get to this really fun realization where you might be able to do things, and if you're unlucky, you're going to realize that, wow, because this is an afterthought, and because this feature is tied into all of these other features, there's not really much I can do. I have to rewrite this entire feature if I'm going to make this performant. And if I want to rewrite this, if I'm really unlucky, I'm going to have to rewrite the entire system, because it's a backbone feature that was designed without performance in mind. And then you're going to go on a tech talk and explain why a premature optimization doesn't mean that you shouldn't make things performant by default. And there you are. So what I want you to take away from this is that if you're dealing with a second generation code base, aka no documentation, poorly written, and it's just a big huge mess, and you're trying to figure out a performance issue, that is, the good news is that that's usually the easiest thing you can do. The worst thing is usually to try to figure out why something is bugging out or why something isn't working or things like that, especially when it's a third-party integration. Anywho, so fixing performance issues is basically the same strategy regardless of what code you have. You try to figure out, okay, what are the performance bottlenecks, and then you try to look at the metrics of the system. What is the CPU, like what does the CPU usage look like, what is the memory usage, is there a specific endpoint that is unperformant, and then try to create then do like a profile of the hot path through the code and see if you can find some culprit which is taking a lot of time, things like that. And when you identify where the issue is, the bottleneck, you try to figure out, okay, how can you solve it? Usually reverse engineering the thing, or trying to figure out why is it working the way it is. Is there a way for me to use my amazing big O notation skills to figure out a cleaner way of executing this code? And you can either fix it, or you can just go to your manager and say, I'm very sorry, but this code is running as fast as it can given the circumstances. If we want to fix it, I'm going to have to rewrite this, and just present those options. That's practically all you can do in that scenario. Have a great day.